Hello, hello. This is lesson 5-4 on function notation. By naming a function f, you can write using function notation. So this right here, this looks very similar to y equals mx plus b form, right? Because it means the same exact thing. This is read f of x equals 2x minus 3. The notation f of x is just another name for y. So it's kind of like when you call me Mrs. T, I'm still Mrs. Tremblay. It's just another way to name me. When function notation is used, the parentheses do not imply multiplication. So this doesn't mean f times x. It's just naming it f of x. You can use letters other than f as well to name the function. Like you could say g of x, h of x, j of x, k of x. Those are often used to name functions as well. So let's talk about how to evaluate a function. Basically, what we'll do is we'll give you some different values here, and I want to know, hey, when x is -4, what's the value of the function? And when x is 3, what's the value of f of x? It's kind of like when you have those specific domain values that I want to know. This is good practice for that. So this is evaluate the function when x is -4 and 3. This f of x represents the value of y. This is just your x. So if I'm telling you x is -4 and x is 3, that just means I want you to solve for f of x for when x is -4 and when x is 3. So what we do for that is we say, okay, when x is -4, so the function of -4, when my input's -4, that just means I'm taking a -4 multiplied by 4 plus 7. So when x is -4, -4 times 4 is -16. I'm sorry, -4 times -4 is +16, and 16 plus 7 is 23. So there's part 1. But I also want to know what's the value when x is 3. So the function of 3 means -4 times 3 plus 7. So the function of 3 would be -12 plus 7, which is -5. Let's try another one. Now, g of x means the same thing. This is saying y equals 2x minus 5, and I want to know what's y when x is -4 and when x is 3. So the function of -4 for this one will be 2 times -4 minus 5, and I'm sure you want to keep change that. Go for it. 2 times -4 is -8. -8 plus -5, yes, is -13. So the function of -4 is -13. And when it's 3, oops, I wrote an F, put a G there, I would take 2 times 3 minus 5, or plus -5, whatever floats your boat. And I have 6 minus 5, which is 1. Let's try one more, just in case you haven't had enough. I'm sure you get it, but why not? All right, so k of x. So k of -4. Now this one's a little bit trickier. This says -x. This means the opposite of what x is. So the opposite of what x is -1. What's the opposite of a -4? Yeah, it's a 4. So 4 minus 1 is 3. Okay, and then finally we have k of 3. This means the opposite of 0 minus... Oop, why did I put 0 in there? I don't know what's going on. Sorry, it's very early. It means the opposite of 3 minus 1. So for k of 3, -3 minus 1 is a -4. And voila. Okay, so that's part 1. I give you the x, you plug it in, you give me the different function values when x is those values. Now sometimes I'm going to actually tell you what the function is equal to. So it's like I'm giving you the value of y, and then you have to tell me the value of it, the value of the function. So it says, for h of x equals 2/3 x minus 5, find the value of x for which h of x equals -7. Now up here I said x equals -4 and 3. Here I'm telling you what the function equals. This means y is -7. So for this one, if I give you the whole thing, I don't just say x equals, I give you the whole amount, you're going to plug that in for the y. So this would look like -7 equals 2/3 x minus 5. I'm sure that looks so familiar to you. You're like, yes, I love solving two-step equations. And if you're a keep change changer, do it. we need to get rid of the number that's being added to the variable term first. So we add the opposite of that. So we have negative 2 equals 2/3 x, because those are long gone. And then to get rid of a fractional coefficient, we just need to multiply by the reciprocal. That's that multiplicative inverse coming at you. Cross cancel them out. When you multiply reciprocals, you get 1. I need to do that over here too. So the 2's cancel, 3's cancel, x is left, and I can actually cancel out those 2. I'm left with 3 times a negative 1. So x equals negative 3. That's it. All right, let's try another one of those. F of x equals 6x plus 9 when f of x equals 21. So that means replace f of x with 21. So 21 equals 6x plus 9. Another little two-stepper. Get rid of what's being added to the variable term. And 21 minus 9, that's 12. 6x is left over here. Divide by the coefficient of x. And yes, when f of x equals 21, x is 2. So it's like I'm giving you the range and you're telling me the domain. Kind of. Okay. For this one, I'm saying g of x equals negative 1. That means this g of x gets replaced with negative 1. So negative 1 equals negative 1/2 x plus 3. It's just another little two-stepper. I'm going to get rid of this 3 by adding a negative 3. So I have negative 1/2 x left. A negative 1 plus a negative 3 is a negative 4. Okay, I want to get rid of a negative 1/2. So that means I'm going to multiply by the reciprocal. The reciprocal for this one would be a negative 2 over 1, which is the same thing as negative 2, right? So a negative 1/2 times negative 2 over 1, negative times a negative is a positive, x is left. Over here, I want to also multiply by negative 2, or negative 2 over 1, the same difference. Negative 2 times negative 4, that's 8. So when g of x is negative 1, x has to be 8. So that's that. Now I want to talk a little bit, we'll make a geometry connection, and we'll talk about translations. Okay, so translation, just remember that word for translation. The simple word for it is a slide. In vertical translations, and vertical basically just means up or down. So in a vertical translation of graphs of linear functions, the graphs have the same exact slope, but different y-intercepts. So when you have a line and you're translating it, you're not going to change its steepness. You're just shifting it up or you're shifting it down without changing the slope. So this asks you to do some graphing, and if you don't have that ruler, you're definitely going to want it, so hit pause and go grab it. Okay, welcome back. Alright, this says to graph each and compare it to the linear parent function, f of x equals x. And the parent function, it's just the most basic one that you can have. And with linear, it's just y equals mx. That's the easiest way to go. That's the simplest one, so it's called the parent. It's the mama bear equation. Or I guess the daddy bear. Either one. So let's graph this. That's what it says to do first. If you're graphing f of x equals x, again, this just means y. You know how to graph y equals x. It starts at 0, 0, because there's not a plus b, and when nothing is added, that's your y-intercept. And the number in front of the x is a 1 when you don't see a 1. So this means from here I go up 1, right 1, up 1, right 1, and graph my line. Should go all the way through the middle. The most basic one of all. Alright. So there's the first one, and I'm going to label this. This is f of x equals x. You should label them whenever you have several equations on a line. Okay, now what I want to do is, I want us to graph on the same coordinate plane. I want us to graph f of x equals x minus 3. I'm going to grab a different color here. Okay, so if we're graphing f of x equals x minus 3, again, this f of x just means y equals x minus 3. So my y-intercept is negative 3. My slope is the same, right? Because we said the graphs that are going through translations, vertical translations, have the same slope. So all these have the same slope. We're just changing the b. I'm going to go up 1, right 1, up 1, right 1 again. And since it's the same slope, your line should end up being parallel to that parent function you just wrote. And I'm going to label this one f of x equals x minus 3. And we have one more to graph. Let's see what pretty colors I have in my bag here. I have a purple. We'll go with that. So for this one, f of x equals x plus 5. The y-intercept is 5. So I'm going to make my dot on the 5. And same slope again. So I go up one, right one, up one, right one. Should be parallel. Same slope. Draw your line. And of course we want to label this as f of x equals x plus 5. Okay, now we're supposed to compare each to the parent function. So when I look at f of x equals x plus negative 3, this line right here, if I'm comparing it to the original, the one that's drawn in regular color pen, all I'm doing is taking this line and sliding it down 3 places. So the fancy way that I want you to say this is I don't want you to say slide down 3 places. I want you to say it's a vertical translation, because that's what it is. It's a vertical translation. We're sliding it vertically 3 units down. So that's the proper way to word it. You want to be very proper in math class. And for this one, if I compare the purple graph to the original, it looks like we're just sliding it 5 units up. So instead of saying sliding it 5 units up, we're going to say vertical translation 5 units up. Don't abbreviate, write the whole thing. I'm doing it too. I know it's rough. Whew, I'm exhausted. 5 units up. Okay, it's really that easy. That's it. So if you have the same slope and you see the y-intercept is different, that basically gives you the vertical translation. Okay, so without having the graphs now, you've been given the visual image of what this looks like. Now just look at the equations. I'm giving you this as the parent right here. F of x equals negative 2x. And I want you to compare each of these to that. You're going to tell me what's happening. How is it changing? So notice that in both of these, the slope is exactly the same. The b's are different. That means there's a vertical translation going on. So if this one is y equals negative 2x, that means it's starting at 0. This one would start at 3. So all we did was we slid this same graph 3 units up. So I'm not going to say slide it 3 units up. I'm going to say vertical translation. I think after you've written it 4 times, actually 5, you'll have it down. It's a vertical translation 3 units up. And maybe you've already started the next one because you can see, oh, it's the same slope, but this is minus 5. That means 5 units down. So vertical translation 5 units down. Okay. Math story time. March is reading month. It's also Justin Bieber month, according to our little fundraiser we got going on. Make sure you bring your dollars in so we can stop the nonsense. Or keep it going if you're a fan. I don't think I am anymore. Okay. The graph shows the number of, oh, and I don't have the graph. Let me show you a picture of that. I do have my notes packet right here. Just give me one moment. Where are you, little graph? Talk amongst yourselves. Okay. So, here is the graph. Your paper has one. This is when I just copy it originally what it looks like before I do the copy paste. So here's a lovely little helicopter. I did not graph that. I actually copied it out of the book and then pasted it onto your notes. I'm not that skilled. My helicopter would not look like that. So this graph shows the number of y miles a helicopter is from its destination after X hours on its first flight. So we can kind of see this graph. As time goes on, it's getting, what? Closer and closer to where it needs to be, or farther and farther from where it needs to be? What do you think? This is the distance from its destination. So, yeah, right here, when it lands there, it means I'm home. I've reached my destination. That's why this line is heading down. It's not how far it's traveled. It's a distance to where it's going. Okay. On its second flight, it travels 50 miles farther. How would that second graph differ from this one? So this is the distance, right? If I'm traveling 50 miles farther, this one started at 300. Wouldn't that mean that I would start at 350? But I'm going the same speed, right? So the slope is staying the same, but my y-intercept is going to be 350 instead of 300. So aren't you just taking this graph and sliding it up 50 units? But I don't want you to say sliding it up 50 units. You know what I want you to say. I want you to say it would be a vertical translation 50 units up. You're done. See you tomorrow.